Welcome back. Um, in this video, we are going to be talking about the biological foundations of learning. And we're going to focus on how the child develops and more specifically take a look at some of the how the brain functions and how that influences student learning across childhood and into adolescence. Prior to talking about that, it's important that we take a look at this within the context of the class. In the previous video, we talked about the effective teacher. It's good to understand a model of effective teaching so as to we can put a context to many of the things that we talk about over the course of the semester. Um, One of the things that's important is that we understand that none of the learning that takes place in the classroom is isolated just to that classroom. More specifically, when you take a look at the PowerPoint that accompanies this video and the readings and in the book, you'll notice that there is a overall model that we're using, and that model can be reflected in like cogs in a wheel. All right, and what you'll notice or what you'll observe is we have our unit on social emotional learning, we have a unit on cognition, and we have a unit on motivation. And while we'll treat each one of those units discretely, we cannot act as if they don't influence or impact the others. They are like cogs in a wheel, they work together. Okay? And so, having said that, when we talk about the social emotional aspects, we notice how it will influence students' motivation and how students' motivation will then impact students' learning or cognition in the classroom. So we address the course of the semester as very holistic. Okay, that all of these things are tied together, even if we're talking about them one chapter or one unit at a time. Having said that, those three units, the social emotional, the cognition, and the motivation, inside of that, we also have our own past experiences and how our past experiences will influence our relationships, how we learn, our motivations, and on top of that, we have the cultural context. That means the cultural aspects of the classroom, of the school, of the community, and how those kinds of things will influence your experiences and your learning and your relationships and student motivation. So we put those things all into perspective as we take a look at the developing learner, both from a physiological and obviously from a cognitive. Now, one of the things that you'll hear teachers and professors and schools of education talk about, you'll hear things like developmentally appropriate practices. As teachers, we're trying to always focus on what are appropriate practices or best practices. When we refer to something as being developmentally appropriate, what exactly does that mean? Think about that for a second. What do we mean by development? If you're like me, when people talk about development, the first thing I think of is physical development. All right? Well, yeah, that makes a lot of sense. We develop, we grow from little kids to bigger kids, from bigger kids to adults, and that makes total sense. But when we start thinking about developmentally appropriate practices in the classroom, we think about it a little bit differently. Now, does physical development play a part? Yes. But we also think about things like what are, from an age appropriate standpoint, like we know that students go through a predictable sequence of growth, right? But we also realize there's a difference between developmental age and perhaps even chronological age. For instance, many of you might have worked with young kids, or some of you do have young children, and you can probably attest to this. Some of them are 6 years old, and they seem like they're 18 years old, okay? That they're wise beyond their years. And you listen to them talk, and you think, wow, where did this come from? Like, where did they learn this from? Okay, 6 years old. Now there are some 6-year-olds that behave and operate like most of us would think 6-year-olds operate, and yet you run across some that are very, very mature, socially mature, etc. And then you run across kids that are 12 years old or 15 years old, and some behave like many young adolescents, and some behave much older, and some actually are somewhat socially immature. So we have to think about our classroom as being a collection of students. While we might be teaching third grade or fifth grade or sixth grade or whatever the age might be, that within that classroom we are going to have a span of different social and emotional understandings from the kids. And the idea is, as a teacher, we're always looking to identify appropriateness, individual appropriateness. Now, luckily, most of the kids are very similar in understanding, social emotional development, cognitive development, etc. And so when we teach a whole class, when we teach to the whole class, we don't make a lot of variations. We don't have to change up a lot of things because many of them are very similar in their understandings. But however, sometimes we're going to find that there are going to be kids that are going to be different cognitively, emotionally, motivationally, and we're going to have to identify those students, and sometimes they'll be self-identified or they'll have plans, IEPs, if you're working in a special education setting. All of us will work with special education students, so we'll have familiarity with IEPs, but we'll recognize that sometimes some of our instruction is going to have to meet the individual uniqueness of each of our students. That means both from a maturity standpoint, cognitive standpoint, etc. All along, we're taking in the social and cultural aspects of their upbringing, of their families, of the school, of the community, of what's going on in our regionally or geographically, and we take that, we pull that all together. That's going to be what we refer to as developmentally appropriate practices in the classroom. Now, in the PowerPoint, you'll notice I give you a list of different objectives and what we're going to talk about, but we're going to focus on the biological foundations of learning. And just what does that mean to us as teachers, and to our instruction, and to our relations that we establish with our students. Okay, and so having said that, you'll notice one of the first things that people think about when we start talking about some of the biological foundations, we start thinking about obviously biology. You think about the physical growth and development of our students. And you'll hear, and many of you probably have heard before in other classes, psychology classes, or maybe in some education classes, discussions around nature versus nurture. All right? So what are we talking about with nature? Think for a second, nature. If it's nature, it is natural, which means that it's something that is genetically part of who we are. Okay? It's a natural. A genetic predisposition. It's our makeup. All right, it's in our DNA. That's what they refer to or think about with from a nature standpoint. Now, nurture is the environmental aspects. You know, the family, the siblings, the peers. What is nurturing the individual as they grow and as they develop? And there's a lot of debate sometimes around how much nature influences human relations, human learning, human motivation, and what aspect does nurture play. All right. Well, some of this can be just circular, and we can go around and around and around. But what we find is many times is that it's a good dose of both nature and nurture that adds to who our students are. There is a genetic predisposition that the students have that influences their personality, that influences their the way that they respond to others. And there's also this nurturing aspect? Do they have someone in their lives that builds them up, that supports them, that makes them feel comfortable in their environment and their learning experiences? All right. I'm going to try to put together a video that will talk a little bit about the nature aspects, and it comes from a gentleman who's a bio neuropsychologist. I can't remember exactly what his title is, but he talks about the developing brain, and he talks about it from a kind of from an evolutionary standpoint. The reasons, the importance of the brain, and what it plays as part of a functioning aspect of human beings. So I'll try to put that together in a clip and post that on the Western Online as well. Okay, but when we start thinking about the biological foundations of learning, we have to think about what is at the heart of it. Okay, learning. Well, when we think learning, we most often think of the brain, right? Okay. The brain is a working organ, okay? It is active, it is adaptive, and it is efficient, okay? When you think about it, if I were to ask you which organ is the one that is the hardest working, burns the most calories, does the most for us, we start thinking about, it's like, okay, well, what do you think about? You think about my heart. You start thinking about different parts of your body, and all along, it's the thinking that we're doing is all taking place in the brain. That the brain is actually the most energy sucking, calorie burning organ of our body. All right. Think about this. If you're trying to understand just how much energy is consumed through our thinking and our studying and all that stuff. Have any of you ever been outside in the yard, working in the yard, or perhaps working out at the gym, or playing a game of basketball, or something that's physically active, and you do that for 2 or 3 hours, and when you're done, you actually feel good? You feel like, oh yeah, I've got a lot of energy. I feel really good. 2, 3 hours. How many of you have studied really hard for 2 hours, 3 hours? I mean, like really studying hard. How do you feel after 2, 3 hours of hard studying? Probably pretty exhausted, right? Yeah. Most of us do. When we're studying hard for a few hours, we feel wiped out. But at the same time, you can go and do something that is physically challenging, or exercise or whatever for a few hours, and you could actually feel good when you're done. So yes, our brain is the workhorse, the engine, okay, of our body. So what is the one of the terms that we'll use, and we'll talk a lot about, and the book talks about, is this idea of that when we start talking about the brain, is neurons. All right, what are neurons? Neurons are where we receive information from other neurons or other sensory organs, integrate that information, which will then determine its output. Okay, so neurons are the vehicle. They're the way that we transmit information from one place of our body to another. All right, and so when you think about the neurons, and there's some pictures in the PowerPoint as well. You think about it, it's like I need to raise my hand, okay, or if I need to kick a ball or something like that. All right. Well, in order for that action to take place, a signal has to be transmitted. And that signal is going to come from perhaps from our brain to, if it's raising our hand or if it's kicking a ball, it's going to come to that outcome or that output, right? Now, as many of you know from my introduction, I'm in a wheelchair, okay? You can see that, all right? Now, I broke my neck, right about here, all right? So, why, if I were to ask you to focus on my leg, okay, and me moving my leg, and I said to myself, I'm going to make my leg, I'm going to kick something, right? Many of you are thinking, well, I thought he was paralyzed. He's probably not going to be kicking anything. And you would be right. But why not? Okay? I'm sending a signal. I'm trying to think, kick my leg, but nothing's happening. Why? Because the impulse that's traveling from my brain to my leg is getting lost. That transmission is getting lost, right? How does it travel? It travels down our spinal cord, the nervous system and our spinal cord. What do we know about our nervous system? We know that our spinal cord and they're called Schwann cells, and those nerves don't regenerate. So when damage is done to those cells, then the signal, think about this. If you have a long cable, okay, let's think of a cable that provides power and wires and telecommunications and everything to a big university. You have this really thick cable, and somebody comes along and just takes an axe and just chops it in half, right? Pulls the cable apart. What happens? Signal comes, hits the gap. Nothing happens after that, right? We've lost communication. We've lost power, lost transmission. Kind of like that with the spinal cord too, right? Signal comes from the brain, travels down, hits the area of damage or injury. It's kind of like a swamp. It just gets lost. The signal is lost. It doesn't know where to connect to on the other side, and therefore lost transmission. Eric doesn't kick his leg, right? So when we think about the brain and how it works, and the neurons, the vehicles by which this information is transmitted chemically, electrically, that this is going to happen, what we find is that signal comes along, and at the end of each signal is, or at the end of each neuron, we have these dendrites, okay? These dendrites are like tree-like structures that are going to receive the information from one neuron to the next neuron, right? I always like to think of it. If you ever look at you think in the Great Barrier Reef, or you think about in the ocean, and you'll see some of the plant life that's just kind of floating in the water right there. What's it doing when it's just floating like this? It's just, the plants, the coral reefs, right? What are they doing? They're actually eating. They're looking for plankton, and the plankton comes along and they're just sucking up the plankton, right? Like that, all right? These dendrites that grow at the end of the neurons are there to actually grab a hold, okay, of that transmission and pass it along to the next neuron. And as you go from one neuron to the next neuron, you've got this gap. This gap is called the synapse, okay? The junction between the two neurons. From that information is going to go from one neuron to the second neuron, okay? And it's going to use those dendrites as a means to kind of jump the gap there, right? Now, why is that interesting to us as teachers? Think about this for a second. These are the paths, the common paths that information travel back and forth, right? Neurons, almost like superhighways, like the internet. You think about telecommunications, these neuronal connections, these neuronal pathways are the way that information is traveling back and forth. Well, the wiring of the brain, not physical wiring, but the neurons that are taking place, that are growing and expanding within the brain, are due to these synaptic connections, okay? These synaptic connections. And what we find is that the synaptic connections that take place are the basis for most forms of memory. So as you do a behavior repetitively, playing the piano, playing Xbox or something like that, you'll notice that some of those motor memories, those things that while you start to do them, they perhaps don't start off very smoothly, But as you do them more and more and more, they become very smooth. Those behaviors become very smooth, all right? So what exactly is going on there? Well, those synaptic connections that have been used again and again start to form the basis for memories. And where does this start to take place? It actually starts to take place prior to birth. All right. If you take a look at the in the PowerPoint there, you'll notice that the brain begins to develop develop at around day 25, really, really early in utero, right? These neurons begin reproducing. They call that neurulation. All right, producing billions of neurons, and you'll understand why we need so many neurons as we talk further about this. All right. These neuronal connections that begin to form in utero when the child is like early on in the first trimester, when you think about the synaptic connections that are taking place, they call that synaptogenesis, which, think about it for a second. Genesis just is kind of the beginning. Synapto, we're talking about synaptic connections, so we're talking about the beginning of the synaptic connections, right? Those are associated with reflexes, all right? Now remember, reflexes are things that take place involuntarily. We don't have to, when the doctor has you cross your legs, and then they take the little rubber mallet and they hit the knee, and the knee just jumps up, and the leg jumps up and stuff like that, right? That is a reflex. It is not a learned behavior. It is something that happens, right? When you take a look at a baby's foot, and you rub the bottom of the baby's foot, and you see the toes and what they do, or you put your finger inside of an infant's hand at a very young age, they'll grab a hold of that finger, right, or anything. Could be a pencil or whatever else. Those are reflexes, and those take place. Those are developed in utero. Okay, now, because of this neurulation and this synaptogenesis that's taking place in utero, okay, it's happening in the developing brain. It means that it is a very vulnerable time for the brain and its development. So what does that mean? That means that doctors are very aware of the kind of things that the mother may do while the child is in utero, and they say avoid high levels of drinking because that will lead to fetal alcohol syndrome. Fetal alcohol syndrome will emaciate the brain, reduce the size of the brain and the function. Taking certain medications, certain stimulants, stay away from, the obviously things such as opioids or cocaine or other kind of things like that. Those will have a detrimental effect not only to the child's brain but to the mother as well. And so they realize what happens. They call them teratogens. Okay, that just means they're things that are outside of the mother that they ingest. That is I don't want to say poison. It's not necessarily poison, but it is an outside event that's going to influence or impede the health of the child. And these teratogens, think about lead in the water, right? You think about parents, the mother ingesting fish with high levels of mercury. These are the kind of things that enter the mother's system, digestive system, which then eventually will lead to the growing child, and that will have an impact on their overall physical health and well-being, not only their brain, but certainly could impact other areas as well. So in utero, prior to birth, the brain is highly vulnerable. When you think about after the child is born, the rapid growth of the child as well and their brain, you'll notice that about age 2, a child's brain is roughly 20% of the adult-sized brain. By age 6, a child's brain is roughly 90% of an adult-sized brain. And by age 11, the child's brain is roughly 95% of that of an adult-sized brain. So by age 11, the brain is almost fully developed from a physiological standpoint to that of an adult. But during that period, you're going to see lots of development that's going to occur and revision of these neuronal connections, meaning the types of changes that these neuronal connections will make. Now, most of these, well, I shouldn't say most of these, all of these neuronal connections that are being generated, created, these synaptic connections that are being formed and stuff like that, the cause is from environmental experiences. What does that mean? That means there needs to be a stimulus that is going to create the need for that neuronal connection to form. If the teacher is asked a question in the classroom and there is a need for me to raise my hand, I physically got the ability to do that. I don't need to do that. I can talk right now without my arm raised, right? But there's an external event that calls for me, like catching a football, right? Passing a basketball, whatever it is. There's an environmental event outside of the developing child that calls for that that neuronal connection to be made. Now, the areas that are most often impacted you're going to see are things such as our senses, our language, our speech specifically. You'll notice in languages that there are certain sounds that are not produced in one language that are produced in another. For instance, if you are looking at the Japanese language, they don't produce the sound, they don't have the sound L, they don't have the letter L, so they won't say words like, as far as when we think about it's glowing, or he was laser focused, or just listen to me, or they're in love, L words, right? What they do, because they don't have that sound, they didn't learn at a young age to produce the physical, have that physical motor production of la 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 la. They didn't have that, so they can't necessarily produce that when they didn't have that exposure at a young age. So if they don't have it, they don't form those connections, they don't have the motor reproduction, and therefore what we find is that they often replace it with a sound of R. So instead of loving someone, you would rub somebody. Or if it's glasses, it's grasses, okay? Because they can't produce a sound that they don't hear or they don't have. And so that's what we see is if there's not an external event, something that will require or create those connections, they won't be there. And all along the developing child, you're going to find this thing they refer to as a blooming and pruning process. Blooming, like flowers that bloom, prune, you cut back or you prune back the bushes, right? That's what they're talking about with these neurons and neuronal connections. Over the course of a lifetime, people will routinely prune back neuronal connections that they don't use all along while other neuronal connections are blooming. Okay, we'll talk about that more specifically. Now, the strongest connections, the ones that we use again and again and again, go back to playing the piano, go back to playing the Xbox or whatever it might be. And you think, wow, look at their hands typing. People sit there typing, they're just looking and talking to somebody and they're sitting there typing 80 words a minute. It's like, how the heck do they do that, right? What we find is the ones that have the strongest connections, those pathways, remember it's a pathway, a neural network going from one place to the other, all right? Those pathways become myelinated. Myelin is a protein, and that protein or that neuronal connection becomes myelinated, and when that myelination takes place, it acts as like an insulation. Well, cables, wires, things like that that are highly insulated are going to become more efficient. If you think about it, if you've ever been in a store and you're buying an extension cord, you could buy those small, thin extension cords that you use around the house, but you don't use them outside, like a 100-foot cable, extension cable, cover a long distance, because what happens? You plug the extension cord in at the house, and you're 100 feet away and you're cutting or you're doing something with that, you're going to lose energy, you're going to lose power over the length of that 100-foot cable. All right? So in order to maintain a higher output, they insulate. That's why you have different gauges of extension cables. You have a 10 gauge or a 12 gauge or a 4 gauge or whatever it is. You have thickness, different thicknesses, right? You have different insulating variables. That's what's going on in our brain too. The pathways that are often used become myelinated. That protein builds up around it. That acts as an insulator, which allows it to become more efficient and quicker and faster. Okay? Now, along the time that the kids are developing from childhood through adolescence, we find that there is a lateralization of the two hemispheres. That means there's greater integration of the brain, which will eventually result in smoother behavior, smoother transition. So we have the different sides of the brain, right? And those different parts of the brain do have different functions, meaning that perhaps the kinds of things that we'll do from a language center, speech, etc., etc. And when we learned that those different parts of the brain, which is really interesting, many people have heard of left brain or right brain. Like, I'm more left brain or I'm more right brain, depending upon if they're maybe more mathematical or if they're more language oriented or something like that. You've also heard that you only use perhaps 10% of your brain. Or if you've ever watched that movie with Scarlett Johansson, I think it's Lucy, where she takes and ingests this chemical which then allows her to use or maximize the output of her brain. What we find is all that stuff is just mythology. It's just, it just is what it is, all right? We think about it, left brain, right brain. What exactly does that mean? Like you're using one dominant center, or I'm better at using this one side of the brain? Well, what we found out from research is when we ask people to do in an MRI, which is a magnetic resonant imagery, you've seen those people go into a little tunnel and they're laying on their back and you hear the machine boom, boom, making noise, and it's taking an image of the brain and its activity and its output. Or even if you have things attached to different parts of your brain, what we find out is when students are doing, or people in general, are doing any sort of activity that requires them to have an output, a mathematical, language, memory, whatever it is, that no one side is isolated for an event. That the activity of the brain is taking place. The brain is hot all over. There's different parts of the brain being activated at all different times. So this idea of it being dominant, left brain or right brain, what we find is each activity really draws upon different parts of the brain. And as we get older, because of all those activities over years and years and years, what we find is that those parts of the brain being activated, creating these neural networks, these connections, they become more and more integrated over years. And the more that they become integrated, the more likely they are to have smoother transitions, operate more efficiently, operate more effectively. Okay? One of the things that we've learned as well is that, well, I'll give you an example about the importance of the lateralization. All right, if you've ever watched Grey's Anatomy or any show that there's a neurologist or somebody who's going to be working on the brain or something like that, okay. You'll see them, like in Grey's Anatomy, what is his name? Dr. Patrick Dempsey, Dr. McDreamy, or whatever it is. Anyway, you'll notice a lot of times before they do brain surgery, before they're going to do anything, they'll start mapping out. So they open up and they take there, and it's painstakingly long how long they take to test different parts of the brain. What they're doing is they're actually generating a map of different neurons and different things that are going on. Because as you get older, the integration, let's call them wires, right? They're not wires, but let's say the brain becomes more and more wired. And with all those wires all integrated like this together, all of them being tied and connected together, now what we realize is you go into the brain to take out a tumor or do something or whatever else, you have to undo some of these things, and suddenly those pathways and connections are disrupted, and wow, big results, big effects, right? That's what we learn, is that as you get older, these connections become more and more ingrained. Therefore, trauma to the brain as an older person from a surgery, from an accident, has a real debilitating effect on the person. Whereas a 6-year-old could have perhaps a benign tumor or have something, an accident, they could have a quarter, a third of their brain removed at that age, and they bounce back. And in a couple of years, you never know anything happened because it rewires. All that wiring takes place. Much different when they're older than when they're younger. Now, we've also learned that the brain, from a flexibility standpoint, adaptability standpoint, it's very different than what we thought of just 30 years ago. We used to think that they talk about periods. We have this critical period. We used to have this more of a notion of a critical period of learning, meaning that young children are exposed to certain environmental influences, which is going to be required for healthy development of the brain. Meaning, in order for you to be able to speak a language fluently, to learn how to play something, that you have to be introduced to that at a very young age, and if it doesn't happen, you're never going to learn it. You've heard the old trick, the old adage, you can't teach an old dog new tricks. That is because there was a time in their life when they were to learn this stuff, and if they didn't learn this stuff then, it was going to be critical to their overall development. Now, what we've learned is that it's much more likely that we should think about things as a sensitive period, meaning that if you start at a younger age learning another language, that the likelihood of you becoming more fluent at a younger age of a second or third language or something like that is more likely because of those connections that are formed when they're young. However, what we've understood or learned to understand is I didn't start learning Spanish until I was 11, became fluent after a certain period of time, but that doesn't mean like it should have happened that way. I should have started much younger. That's the exception. We understand is, wait, you can become fluent. You can learn an instrument and become really talented in an instrument, starting these things at a much later age. Now, had they started younger, it's more likely that they would have been fluent at a younger age, and their fluency might even be a bit better. But the idea is that it's not fair of us as teacher to think that if you don't get something at a certain age, that critical exposure to something at a younger age, that your learning is going to be totally, thrown off, or that you won't be able to produce that that understanding or that produce that muscle movement, etc. So we look at sensitive periods as being much more likely that that while the window might be a little bit more closed, it's still open for you to learn. There's an opportunity, okay? And that flexibility does decrease with age, which is the more the brain becomes integrated, the more likely or less likely that is for a person to be more adaptive, okay? So the more integrated, that flexibility starts to decrease. Now, as a teacher, how do we put this together and incorporate this into our own instruction? Well, what we realize is in order for the brain to grow, it must have two things. One, stimulating experiences. Those stimulating experiences are going to be the catalyst for those neuronal connections to begin. And secondly is we need an enriching and social environment. The more social an environment, the more enriching the environment, the more connections we're going to make, which are going to be the basis for those memories, which will be the basis for what we will learn. From a constructive standpoint, we're building on prior knowledge. The more knowledge we have when we're younger, the more experiences we have when we're younger, those are going to be the stepping stones to future learning. Creating more neuronal connections. Okay? Now, when you think about learning as a function of the brain, I'm a teacher. I teach my students, you'll teach your students, and we oftentimes focus on, I want my students to learn stuff, right? So, what do I need to think about beyond just content, right? I need to, if I want to do it in a healthy fashion, to promote learning in a positive manner, I want to expose my students to a stimulating environment, one that will ask for them, or not ask, but will generate neuronal growth, right? Remember, neurons are what make all body and brain functions possible. Those are the vehicles by which we transmit information. And they're experience dependent. They are environmentally dependent. That means when someone shows me something for the first time, when I taste something for the first time, for instance, it's like when you go to cultural events, and when you go to a cultural event and they have foods from around the world, and you're thinking to yourself, oh, I'm going to try this soup. It's like, I don't know what it's like, but let's try it. And you taste it. What you'll find as an adult, you say, oh, that tastes like this. Aha. You're creating a connection. This soup is very spicy. It also tastes like this. And now you're creating a connection. Now that's for us as adults at a cultural affair, testing foods from around the world. Every time we taste something, we smell something, like, oh my God, that smells like, there's something burning. There's a difference between wood burning and like electrical, something that's burning, that's wires that are burning, right? We know those different smells because we've been witness to it. You're at a car, you're at a tractor, and you lift up the hood, you're like, oh my God, that wire is burning, I can smell that. Versus I'm at a bonfire, or we create all these different schemes, all these different types of experiences. They are the basis by which we will form these memories and generate new memories. So as a teacher, we're always thinking about trying to create that stimuli from outside that will help facilitate students connecting previous experiences with new ones. When stimulated, neurons reach out to neighboring neurons by growing those dendrites, right? Now remember, we need to, as teachers, to encourage growth across adolescence and into adulthood due to pruning. Meaning, if we're not using those neuronal connections, they will be pruned over time. And as a result, we have to facilitate more experiences so that our students will be creating more and more neural networks. Think about, you've heard the expression, if you don't use it, you lose it, right? That's the pruning aspect. And so that's what we do as teachers, is try to encourage the growth of these neuronal connections. Now, with repeated stimulation, the number of connections between the neurons increases, which creates what we refer to as automaticity, right? They become so efficient. The pathways become so efficient with communicating with one another that they speed up really quickly. Automaticity. That's like going over your times tables again and again and again and again. And pretty soon, you don't need to pull out your fingers. You don't need to pull out a calculator. 7 times 6 is 42. 8 times 7. You just go through it. Boom, boom, boom. 4 times 4. 5 times 9. You just have it. You don't need to think about it. Automatic. Driving a car. Remember when you're learning to drive a car? Hands at 10 o'clock and 2 o'clock. You're driving along. And someone says, hey, look over there. And you're like that. You don't sit there and spend your time because you're nervous. You have tunnel vision. You're looking straight ahead, right? But as you get more and more experienced, more automated, know how to drive straight, you can look to the side, you can turn the radio, you can eat a sandwich, you can do lots of things. Things become automated much easier. Now, our brain as a whole is energy efficient. Remember I said the brain is, as far as an active, adaptive, and efficient organ. What does efficiency mean? If I'm able to post that video that I was talking about the brain and the developing of the brain, it's like 5 minutes long, or it's much longer. I'll give you 5 minutes of it. But what you'll notice is the brain, from an evolutionary standpoint, is helping us to survive. It is helping us to solve problems. And if it's doing those kind of things, and it burns lots of calories, and we at a very young, and by young I mean by humans at a very young species, we think about that, they didn't have a lot of calories to burn. So that brain has to operate in a very efficient manner. Do not spend a lot of time wasting calories on silly things. That's why we realize that students, people in general, when we're learning, we always want to take the path of least resistance. We always like to be as efficient with our brain as possible. So when students come in and they say things like, Dr. Eric, do you have this like in a video? Can like watch a video? You know, it's like, I had to read that chapter 3 times last night for me to understand it, or I had to read this passage 3 times. I'm like, oh yeah, that happens sometimes. And they're like, yeah, but I'm 18 years old. Why do I have to read something 3 times? Because you didn't get it the first time. Because you have to apply energy to learn and to change and to modify things. And they're like, oh my God, it's so much work. Because our brain is trying to be as efficient as possible. They want us to, as humans, it wants to get everything the first time. It just doesn't work that way, okay? But our brain is trying to be lazy as often as possible. Now, how does education affect brain development? Now, there's this concept we refer to as neuroplasticity, okay? That's the brain's capacity for structural change as a result of experience. Structural change. Does that mean that the hippocampus or the prefrontal cortex is going to move to someplace else in the brain? No. What it means is that these integrated networks, these neuronal connections, these pathways that are created based on experience is going to alter which connections will be maintained and which ones will be pruned, which will then change some of the structural component and the overall efficiency of our ability to process certain information. Now, when we think about it as a teacher, I want to create an environment that's going to be enriching, socially enriching to the student, so that they will have new experiences, because with new experiences, they're going to have to process that information. With processing that information, if it is new, hopefully it will be stimulating versus something that's old and you've seen it a bunch of times before, you get bored with it. Something that is stimulating, and that stimulating is going to then help us remember, creating connections, remember stuff, which will then eventually help us solve problems. So by providing students with enriching environments, stimulating experiences, that is going to facilitate our eventual problem solving and remembering of information. New connections to old stuff, new pathways, okay, will help us solve a problem differently in the future. And that experience, if we do it a lot or use it a lot, will create perhaps a myelinated connection, which will then allow us to be more efficient, as well as be able to grab that information at a later date. Now, as a teacher, we have to think about the 2 terms, brain structure and brain function. Now, brain structure are the parts of the brain. Brain function is how the brain works. Now, you've seen pictures of a brain before. Whenever I think of brain, I always think of that gray, squiggly and stuff, and kind of like cross sections of it, like a person who's doing a autopsy in CSI or some show like that. But when we think about what the brain does and how the brain functions, we're much more interested. We recognize that it has structures. You guys have all seen the different structures, different areas that control speech, certain areas control vision or reading or hearing or smell and all of that stuff. I'm less interested in that stuff or how the brain grows. What we are interested in is how the brain functions. Now, keep this in mind. This is really interesting. I always love to talk to students or to other adults, and they'll say that they watch this movie. As I've gotten older, I get more and more sappy. So I watch any movie, sports movie, any kind of movie. It could be an Adam Sandler movie. And there will be moments in the movie that I'll be touched and I'll be like, I'll start to well up, or I might even tear up or cry. And it's like, oh my God, really? And you'll hear people say like, that movie was so heart-wrenching, or that movie really touched your heart, or something like that. And I'm thinking to myself, really? Now I know exactly what they're saying. They're saying emotionally something came over them that they didn't expect and it just happened, right? And you think it's your heart. Think about that person that you have a relationship with. Maybe someone that you love, or someone that you like, and you see them and it just makes your stomach feel a certain way and makes your heart race and all that stuff. And it's just like, oh, your heart. Your heart's not doing any of that. All of that stuff is taking place in the brain. That movie that you're watching that makes you cry, or that person that you see that excites you and your heart starts to pitter-patter, that's brain stuff. But it's not romantic. I don't think that's going to be a very good Valentine's card. You know, like, I love you this much, and you show a big picture of a brain. I don't think that's going to be a very, very winning Valentine's card, right? But that's where it's taking place. So we talk about the brain, where all this stuff is going on. And what do we care about? Structure, to some extent, but really function. How does the brain function and impact my student as a learner? And one of the things that we know is that the prefrontal cortex doesn't fully develop until roughly age 25, till their mid-20s. Well, what is the prefrontal cortex? Right? What does it control? Well, the prefrontal cortex controls logical thought, creativity, critical thinking, organization, inhibitions, problem solving, all of that stuff. And I'm thinking, wait, those are all the things that as teachers we talk about. Helping our kids become problem solvers, helping our students become critical thinkers, helping our students to become more logical, to be less impulsive. And you're telling me that that doesn't develop till they're age 25? And I'm teaching 4th grade? What am I going to do, right? That's the ticket. We have to think about the the functional aspects of how the brain works. What kind of things are going to impede or influence students' development, right? So as a teacher, we realize, and you'll see this, and in the PowerPoint, I give you an example, and they have a little study of talking about, it says, why do most 16-year-olds drive like they're missing a part of their brain? Well, the truth is they are. No, just kidding. What they are is that prefrontal cortex is not fully developed, which leads to or allows them to be perhaps more impulsive. And with impulsivity, okay, leads to bad decision making. So they get behind the car and they start driving, and they see something and they want to get somewhere fast, or they love how fast the car can go, or maybe they're driving a manual transmission and they love, going from first to second to third to fourth. Then they're just flying. It's like, what the heck's going on? Like, why are you what are you thinking? And they look at you and they give you that answer. I don't know. Now, do they really not know? Well, what we realize is, with experience, with age, they develop better habits, better thinking, better thought processes, all along while the prefrontal cortex is developing, which is going to inhibit or limit the impulsivity as they get older, right? So what does that mean for us as teachers? That means we deal with a lot of impulsive kids. Are they naturally impulsive? Yeah, they are. That's how their brain is working or not working at that time. Why don't they think logically like me? Because you're an adult. You've had these experiences. You've had these connections. You've created these pathways. That 6th grader has yet to do that. So you have to be patient with the process of the growth that is occurring intellectually for each of your students. Now, what we realize is that those, especially during adolescence, that these synapses are still forming. They're still forming and they're still pruning. Okay? With exposure to new knowledge, new experiences, new stimulating, enriching environments, they're going to be blooming, blooming, blooming. All along, there is pruning, pruning, pruning taking place. In fact, pruning as much to 30,000 neurons each second. Now you understand the need for billions of neurons in utero. The importance is that, from a structural standpoint, is that it allows us to acquire new knowledge and skills and adapt to different circumstances all along while certain neurons are being pruned. Now, myelination continues throughout lifespan. The importance of this is that as that myelin, that protein, is coating certain neuronal connections, that those things are going to lead to greater efficiencies. Those greater efficiencies are going to help us as doctors, as teachers, as engineers, as whatever it is, to be more efficient with whatever skills that we may need to perform. It's also important to recognize that in adolescence, we have different things going on, different than when they were children, and different from when they were adults. Now, in adolescence, we like to think from a cognitive standpoint. We like to think of a cool network and a hot network. The cool network, from a cognitive standpoint, cognitive control network standpoint, is that the function of that prefrontal cortex. Okay, that's important in decision making, planning, emotional control, etc. Right? Most of that structure is in place during adolescence. What does that mean? That means that while the prefrontal cortex is still developing, much of that stuff is already in place, meaning that they can problem solve, that they can be less impulsive, that they can problem solve. However, at the same time during adolescence that they're getting greater control of that prefrontal cortex, they have this social emotional network we refer to as hot cognition. It's that limbic area of the brain. Limbic is that brain reward center, right? And all along that adolescent time period, we'll see that there's increases in dopamine production during puberty, and that leads to heightened sensation seeking, okay? And that continues into their 20s. So, how do these two coexist? We have kids that have control over their impulsivity to some extent, their problem solving, their logical thought, everything. Yet at the same time, because during puberty, because of that limbic area of the brain and the dopamine production, and we start to see this heightened sensation seeking, they're working against each other. That's why I can talk to my sons about driving and the importance of how they drive and all that stuff, and I say, hey, don't go too fast when you're going down that road, because ... They step in and they say, I know. That's a gravel road. It's very easy to lose traction, spin out of control, get into a ditch. Or they say, if you're going really fast, you hit a bump, you hit a pothole, shifts the way that you're driving, suddenly you're in the ditch or you're into another car. They can just tell you that stuff. And then they're with their friend and they're driving home. And their friend says, I need to be home by midnight. And it's 11:55. Oh my God, I'm in trouble. Hit it, go. And suddenly they're 70, 80, 90, they're driving really fast. They're like, what the heck? You talked to them. Just earlier that day, they told you every reason as to why you shouldn't be driving at high rates of speed. And 2 hours later, 3 hours later, there they are engaged in the behavior. And you ask them why, and they look at you and they say, I don't know. Because sometimes that impulsivity just takes over and they act impulsively and they really don't have a good explanation. You would love for them to act like an adult and say, X, Y, Z. They're just going to tell you why. But the truth is, they get to a point and they're just like, I didn't even see it coming. It just happened. Impulsivity, right? That is that hot network of the adolescent brain, okay? Now, along those same lines, we're going to see that the logical reasoning abilities of the mid-adolescents, okay, they're able to do that similar to adults. They're going to have sometimes that social emotional network, that limbic system, is going to overrule the smart side. Okay? When you add the presence of peers into that, it makes that network even more bold. Suddenly they are acting in a much more irrational manner. Why? Because their peers were there, they're trying to show off. By showing off and doing these things, it releases greater dopamine, which then, it's kind of what takes place in adolescence. So when we think about the brain as a teacher, we realize that in order for cells to fire, okay, cells that fire together wire together. The more often that these cells interact with one another, that they're firing, cross the synapses, jumping the synapse, and going to the next neuron, they're wiring together. That firing together, starts to wire, which is that myelination that takes place, becomes much more efficient. And the other aspect of it is to use it or to lose it. If you don't use it, it's going to be pruned, okay? And so therefore, you want to use it, otherwise you're just going to lose it, right? So that's kind of a good synopsis of the brain and how the brain works, and you can see a lot of the commonality or similarities between how teachers teach based on the physiology of the brain and how the brain functions, how the brain works, right? Now, one last thing as it relates to the brain is how to evaluate things when you read that are brain-based educational tools. You'll see things like luminosity, okay? You'll see advertisements. You'll see things like they'll say, oh, do this when the kids are young because we see that the kids are, they learn more effectively when they have the Mozart music, the Mozart effect. And what we realize is that stuff is, most of that stuff is just kind of garbage. Does it hurt the kids? No, it doesn't hurt them. Does, as you get older and you sign up for luminosity and you practice those different types of skills and problem solving things, does it hurt anybody? Of course not. But the brain is not a muscle. You don't work the brain like you do like a bicep or a tricep or something like that. You do have experiences, and those experiences become the foundation for future learning, but you can't just work it like a muscle, okay? So anytime you're evaluating anything that's educationally based, and they say it's based on brain research, sometimes I watch a Shark Tank and I listen to some of these people saying, oh, they read this and they read that, and I'm thinking, oh my goodness, don't buy that product, okay? Because a lot of that stuff is not really truly tested or found to be credible information, done with studies, etc. It's a lot of anecdotal information. And so as a teacher, you always have to take a look at the tools or the information that you use in a classroom. If it's based around learning, brain-based educational tools, there has to be a track record, there has to be evidence to support that material. So I'd be very leery on the kinds of things that you would use in your classroom just because somebody says that they're based on brain-based education or brain-based research. All right?